Hi, this is Jared Yost with Innovate Technologies. I'm a senior GIS analyst with over 20 years of experience working in private, public sectors. Specifically, I've spent a lot of time in both the federal and local government levels, assisting them in developing their GISs. And I'm looking forward to presenting to you some information about using ESRI's Geoplanner for suitability modeling. I hope you find this useful. So Esri's GeoPlanner tool, uh, man, it's extremely powerful. And to talk about all of the different things it can do would take a significant amount of time. Here I am with 30 minutes to work through on this presentation. I'm not going to cover all of it. I'm just going to say that it has a lot of potential. Has a lot of potential for uh, presenting and analyzing information efficiently. And what it really does, this is my key takeaways. It takes the black box out of decision-making models. So we're not hiding things behind the screens. There's no wizard in the background. It brings the data to the forefront and it allows you to manipulate the data and select from the variables very easily to see your results. One of the key parts about this is it's also very iterative. So you can try a scenario 5 different ways, 6 different ways, and the tools that are embedded within GeoPlanner will present you the results, and it will present you the results in context, and you can join data to it to enhance it so that it provides information even outside of the original context when you ran your calculations. So it's an extremely powerful tool. And just one piece of it are we touching in this presentation. So there are some prerequisites for the GeoPlanner solution to work. You need to have an ArcGIS Enterprise set up. You need to have a named user license to the GeoPlanner tool. ArcGIS Pro is a requirement. Image Server is a requirement. And ArcGIS Spatial Analyst for Server is a requirement. Now, this may not be a requirement for every instance of using the GeoPlanner toolset, but for creating your own suitability model using your own data, these are the data sets that are required, or tools rather. Okay, on to preparing the data. Now this is where things really get interesting. So as you're familiar with for this, we're going to be using raster data sets for the analysis. So any data that you have, whether it's polygon or otherwise, would need to be converted to raster in order to perform the analysis so that you can easily compare the insides, outsides, and create these summated values. Some of the important, I guess, steps in preparing preparing your data. Let's start with the number one most important thing that I found. I was working on for the last project I performed, I was working on a world data set. What I found is that, the world data sets can have different bounds. So always create a bounding box and clip your raster data set to the specific area that you're going to be working within. So make sure that all of your data sets are clipped by that same, bounding polygon so that they are all providing information back for the same locations. It also prevents any analysis that might happen wherein you have one of the data sets represented, but the other data sets may not be represented. And you would get answers provided back that aren't correct due to the lack of data overlap. Another significant piece is taming the nulls. Null values within your data sets are normally fine, but in this type of analysis, it's better to assign your null values to a range, a number. And what that does is allows the raster calculation to, I believe it allows it to function more effectively. And what it really does is when there's not a clean overlap of the data, it allows it to generate a correct answer between the two pixels. Bit depth is critical. I got hung up on this one when I was originally setting up my data for this analysis. So you need to make sure that your pixel depth is consistent amongst your data sets. So make sure that your pixel depth is appropriate for the range of the data that you're presenting, and consider that this is a mosaic. So your summated range, total data sets, when they come back together, it needs to all fit into that as well. I believe it requires that this is in a TIFF format for moving through the weighted raster overlay tools. Some other key things is that there is a tool set on GitHub for using or generating these, getting the weighted raster overlay tools for ArcGIS Pro. So you want to make sure you go out and get that tool. So you've grabbed all your rasters, or data sets, you've turned them into rasters. You start cleaning up the data, making sure that you don't have the nulls, the bit depth the same, the bounding box are the same, projection should be the same. You're trying to make sure that there's as little difference as possible between the data sets except for the data itself. And once you get that, you can start running it through the weighted raster overlay tools. And there's a set of 3 different tools that you'll use to run through. The first one is to create a mosaic, and it just simply asks for a name and an input there. The second is to bring in your data sets. So when you run the tool itself, it is taking any of the layers that are in your ArcPro project. So make sure that you have a clean project with just the layers that you want moved into your mosaic in that project. So as you can see on that right-hand side, this is kind of one of the things that it does as it comes in, is that it will, if you've preset your symbology layers to ranges, it will automatically bring them in and start helping you with assigning some range values and the suitability values that it outputs for it, and the label. The label being the one of the most important things, and making sure that the ranges that are associated with those labels are appropriate for the information that you're analyzing. The suitability value, that's something that is a editable value as you move forward in the process. Once you've created your mosaic, for those of you that have published images or mosaics to image server, there's that's another process entirely that would be another 30-minute presentation. But one of the key things on doing that, once you've built up this classification layer for all of your different raster sets, then you'll have your mosaic finalized. Then you'll go through and publish that to the ArcGIS image server. One of the most important keys is making sure that you have the tag set up as a weighted overlay service. The spelling matters, the capital O's matter, capital S matters. It looks for that specific tag to bring it into the Geoplanner toolset. If the tag's not in it, it won't bring it in. So make sure that you remember to put in that tag. Cleaning up the data is the hardest part of the entire process, making sure your data is in the right format, making sure that the mosaic is cleaned up. There are many different things you can do to make your mosaic run more efficiently. Once again, a topic that is at another level and much more in depth than we have time for right now. But get those things in place and you will be able to bring in your own data for the analysis. I should add, however, though, the ESRI has prepared a ton of data that you can use directly within Geoplanner that they've prepared, whether it's elevation data sets, raster data sets for census. They've got environmental information. They have a ton of information that you can use right out of the box if you don't want to use your own data. Okay, now I'm going to take you briefly into the world of the Geoplanner tool. I'm not going to go into details on all the many things that it can do. I mean, we're looking at a week-long course to show you all the tools and how it all functions. Um, just in brief, though, I've loaded up um, created a model, the suitability index model, simple screen that you follow to go through to get to that. And I've added a data layer, the suitability index layer. This is the data that we talked about building earlier. So this is my own custom data. You can use data and add data directly from the ESRI library, but this is the one that we built, which is kind of the point of this. And with that, you have the opportunity to create the model. So we can go to the modeler tool, and it brings up the suitability index tool, and you can select the layers that we're going to include in this. In this set, we're going to include biodiversity, mitigation of climate change. Back up just a second here. Show you kind of what that looks like. So mitigation of climate change. Um, let's see, bring up the legend here as well. So these areas that are in blue are not the most important according to the data that I was using for protecting for mitigation of climate change. Those places in red are the highest um, value or the most important areas to focus on for mitigating climate change. And if we go back to layers again and bring up biodiversity, so if we want to work on trying to protect biodiversity on the earth, where are the areas where we should put our effort into protecting? Those areas, once again, in bright red are the areas that are the highest priorities for maintaining. And there is some overlap between the two data sets as far as what areas are the most important for protecting for biodiversity of wildlife. So let's go back to our suitability index model, and we've got two layers selected here. We have the information about each of the different models you can access, and we'll go to design, and then we're going to set our parameters. So let's just say that we feel right now that biodiversity is equally as important in our model as mitigation of climate change. Now we can go through and select, of those parameters, what point values do we want to give them so that when we score this, we'll see, have an understanding of what is generating the greatest impacts. So we can just go through, I'm just going to do a ladder pattern on both of these. And I've taken the null values, as we talked about before, down to 0. They can have a score. There is sometimes a reason why you would want to have those areas to have a high value. And run that, hit save. And we'll just going to do a test so I can clean it up later. Hit save. And the model runs, and now you can see the new model displayed showing those combined two data sets and those areas that are in red as the highest and most important areas on the map for maintaining and managing to protect both biodiversity and to mitigate climate change. So now we're to the fun part. I've opened up a web app builder, added a few data sets to the map to look at. What's really cool about this is you can add a widget. You can add the suitability modeling widget in, and we'll jump briefly over here so you can see the configuration. You can do a blank model. You can start with just raw data. I believe it will allow you to import it. In this case, we selected data. This is that suitability index model that I showed you from before. And I set it up to allow the export. Once you have that all set up, it adds the widget in, and the widget gives you the capability to select the layers, update and change the values in your model, just like you saw in Geoplanner. But this can be done without a license at this point. This is outside of the Geoplanner license requirements, so that anybody that's using or wants to create a model or a perspective of the data can come in and try changing these values and running it to see what it looks like. So let's launch it really quick and have a quick look at this. So just like before, just as I showed you in the model, right now I've got it at 75-25. We can change it to 50, 50, run the model, and we can see where the highest and most important locations are for protecting biodiversity and protecting against climate change. So it's a great way to make this data accessible to members of your team, your staff, to visualize information and to just get it into the hands of the decision makers so that they can come up with a model that makes sense based on maybe their real world experience in combination with the data that they've been provided. It also gives you the ability to export it as well. So we can export the model, and this model then it exports it as a layer that can be added to any map service. So it's a very handy way to have access to the information. I guess final thoughts on this is, the tool set